let's start our next lecture on Prolog as part of our programming language course. So something different for those who are not here with last lecture. So it's a logical programming language again. So the main idea was, what do we do in this language?
Use inference.
Yeah, we use inference. So first, instead of writing instructions what to do, we sort of provide facts and rules about this world, basically, right? And the funniest thing is that it actually works out to be just like regular programming language. You can use just like regular programming language, even though it works completely differently at the first glance. So let's look at some more. Let's review this. All right, let's start this over. So today our plan is to look at the list data structure, which you basically all know, right? Because we need some sort of structure, right, for more complex operations. We saw the, let's do a notebook here, right? We saw the basic rules, right? Again, so fact, right? Let me see here, program. I'll do a markdown cell. Again, we don't really need markdown cells here, of course, but we'll do just program cell, right? So we'll do. So we do Thursday, right? Day of the week, day of the week, right? Or weekday, right? Weekday, Thursday, right? And I would say this, right? Remember, we have to, if I use capitals, right? That would be a variable, right? So you have to use lowercase, right? That's a fact, right? So weekday would be Friday, right? Right? All right. So now, of course, if I run this again, if I run this, I can now ask queries. So weekday X, right? And basically see what happens. It will give me 2 days, right? Oh, what did I do here? What did I do? Next error. Operator X. Wait. Let me go back.
Should it be with the
lowercase? Yeah.
I think so.
I guess, yeah, I guess, right. See, I'm used to doing, yeah, let's do it over. Yeah, okay, now let's do weekday. X, right. Yeah, okay, yeah. So, yeah, we have the lowercase. Again, it's reverse of the most other languages. So, X, capitalized, ones are the three unbound variables. So, again, not surprisingly, this is a super simple fact database, knowledge base. Basically, only have 2 facts, right? And that's it, right? And Thursday, Friday are actually right. But of course, I could ask, is Wednesday, right? Wednesday, right, weekday. And what will be the answer? Will be false, because it's not in the database, basically, right? So again, there's some analogies with the database languages, some analogies, right? So let's look at more of the Prolog lists. And I don't know how far we got last time. Right. So, and also, of course, we could create some facts, right? Right. The facts and rules. Rules are basically something, you to make inference, because of course, if you only have facts like this, it will make for a really boring program, basically. Right. So, okay. So variables capital, right? Let me see, we got to the list, we didn't get to the lists, right? We got to all our parents, we got to our, we got to the actual, the relationship, right? So puzzle solving, it's good for solving all kinds of puzzles, basically, right? Sort of database queries, natural language parsing, right? Pretty much any type of this type of, which involves tracking down some unknown knowledge, right? Finding out some new facts about the world, basically, right? So pattern matching is a strength. So Einstein's puzzle in Prolog actually might be a good refresher. Do this, but we'll need to do a list. We'll need to do a list for that, right? So rules, queries. All right, and again, so input output. It's part of the. Of course, it's classical side effect. So in Prolog, you have special built-in, again, predicates basically to do writing, input, reading. You can also read terms. You can read text from string, of course, right? So if you need any of these built-in operations, they are in documentation, basically, right? If you forget, okay, should I be using Prolog? I like that question, right? Yeah. There's commercial ones, right? There's no warranty for this particular because this is academic one, right? So, and it's also not the highest performance, right? Again, but it's nice, right? It's pretty decent. It's probably the best performance as far as as far as as freely available. So built-in predicates, right? So this is what you want to look at, right?
How does it compare to the Python's library of predicates? I don't remember the name.
Well, it doesn't. See, I'm sure somebody might have written something like this in Python. I would not be surprised if there is something for handling it, right? But you remember, it's the approach is different, right? The engine here is optimized for this, right? But again, so the downside of all this cool stuff is it adds about a log n complexity to all the queries, really, the inference engine. So something that would take in a regular language would be, I don't know, n. In Prolog, due to the way inference engine works, there's a log n overhead basically, and that's the kind of the kind of like a negative, not a big negative actually. Log n is not so bad, right? But still, there's some overhead, right? So it'd be interesting to see if you have a Python library, you can point me to the library you have in mind, because
I will
check it out. Yeah. So yeah. So this is all the things you need. So loading Prolog source files. For example, you want to printing message, right? You want to say, okay, how to print the message, right? Yeah. You have also print, right? There's all kinds of extra predicates. So predicates, not functions. They call them predicates, right? In Prolog world, right? So, yeah. So but this is it's again, it's very pretty kind of dry here. Okay, but let's continue. So let's continue with lists on language here. All right. So here, right. So list is a fundamental structure, of course, like in most languages, right? So, so you build a list, of course, with square brackets, right? So an element, right? Pretty much most programs will use a list in some way, right? So empty list, one element, two elements, right? So now look at this here, this part here, right? ABC, that's a list of three elements. This also is technically same list as the second one, right? The third one. So ABC, this is also basically it's a list ahead and then the list, right? That also counts as a separate as a list, right? So there's deconstruction, built-in deconstruction, head, tail, deconstruction. Kind of like you've seen this in Python, of course, in some other language, right? When you can extract the head of something, right? Of some structure, right? So so the thing is, so if you need to append things, right? So let's see, we can check if something exists, right? You can check the length, right? So for example, let's see if we can do something here. This is going to be kind of tricky because it requires, so if I do length, right? Length. So length, right? So 1, 2, 3, right? Right. So this is built-in predicate, right? And I have a list here already, right? And I need length, right? So I need to again bind, L or whatever, right? Let's see if this works. It should give me answer 3. It does work, okay? Because it binds the 3 to the length of the list. Right? Kind of weird. It doesn't return. It's not a function, right? It binds the value, right? So now the question is, how would we do some operations, for example, here, right? So we can do also two-dimensional lists. So that's pain. I hope you don't wish you two-dimensional list operations are kind of pain. In Prolog, I will be honest with you, right? So appending, right? So so we could do this. Append, right? So 1, 2, 2, 3, whatever, 5, 7, right? 5, 7, right? And not surprisingly, not surprisingly, result, right? Result, right? If I do it correctly, yeah. And let's run it. It should give me this. Result should be bound to the appended values, right? Yeah, indeed it is. Okay. So now, could we do something now with the value, right? So head tail. So let's see if this is a. Let's add another fact. For example, Let's see, can we do this here? Weekdays. Weekdays. Let's try this. I don't know. It should work, right? So Monday, Tuesday, Wednesday, Thursday, right? I'm lazy, but Friday. Let's see if this is actually legal. Right. Okay. Let's see. This works. Run. It runs. So let's do this. So weekdays. Let's see what happens. So let's do the first, right? So head and tail, right? I think this will, like I remember correctly. Come on, keyboard, right? So head, tail. Let's see what happens. It should give me Monday separately, and the rest of the days should come as part of the tail, right? Let's see if this is correct. I'm just double checking the syntax here. If it works, it's false. It doesn't bound, and I wanted to find it. Or maybe I have to do it like inside. I guess I have to do it like this. Interesting. Maybe like this. Okay, yeah, it does. Okay, yeah. So that's how you do it, basically, right? So that's how you extract something from a list. And now the hard part comes. How would you print? How would you make a predicate that prints something of, goes through, you want to write a loop that prints days of the week, right? Easy in most languages, kind of hard in Prolog, right? So idea would be, of course, recursion, right? You don't have a direct looping is not well supported. Well, you can do it, right? So let's see actually, right? Basic list. Let's do this membership, this concatenation, recursive operation. So
I have a question.
Yes.
Why aren't you using the VS Code for this?
Which one?
Why aren't you use the VS Code in IDE?
Oh, here? Well, because I would have to. Then I don't have a. I have to write the program basically, right? I don't have the notebook because the kernel is Python. You see?
Okay.
Yeah, the one that comes here, right? This is not Jupyter notebook. It's their own thing basically, right? So it's their own notebook format basically. So instructions of how to connect the kernel we have. Remember we installed, right? Sweep history. Let's see, did I do it? No, I don't have sweep. Well, I think, right? Yeah. We never installed last time, right? You were here. Those were here, right? On Monday. We installed it, but to connect the notebook to the Prolog interpreter, how it exists, right? Okay, we can do it. Of course, remember I have it here, right? We can run programs, no problem. Remember, mass, family, right? We can do them here, right? All right. So I can do one here, no problem. All right. You can do list operations, right? List ops fail, right? Fail, and again, it thinks Visual. Okay, here's another thing. Visual Studio thinks PL extension is, I think, for Perl, right? Camel, right? If I remember correctly. Okay, so now of course I can do this, right? Let's make some predicates. Let's define a fact that contains a list, right? Of numbers. And then we will define a predicate that prints the list, number by number. Right, something like this. Okay, we can try this. Okay, so so this will be a fact, numbers, right? Not shocking, right? And then we'll do a list, right? Will be a recursive one. Print numbers, right? Base case, right? Print numbers, nothing, right? So look at this. This is again the Prolog way of doing it, basically, right? So what we do is we write. Well, again, we could of course write ln, right? NL is not needed. So we write the number, right? The head, and then we recurse, right? So this should work, right? We could of course do some extra thing, number, right? I think if I remember, let's look up right predicate. Let's look up right predicate here. We have to search for it, right? Yeah, right one. Can do more. Yeah. let's look at some examples. So print line, print also would work, right? Debug. Oh no, it's I think write is the one, or write ln maybe, because you know, okay. Yeah, same thing. A question is, can you format strings, right? Because we don't really want to. We could, right?
Yeah, there was a format function, I think.
Yeah, there was. So, but it's somewhere here. They're writing and reading, right? So this is right. Attributes back. So it's kind of float number, right? Right term, right? You can do it formatting. Really, kind of. Again, remember this language comes from 70s, right? So some things have added, lots of things have been added since, right? But not everything.
Here is
So
the format function. If you
there's
down, down.
no.
Wait, up, up.
Up.
On the code snippet, a little bit up, higher,
Where do you see it?
higher.
Yeah.
Here.
Oh yeah, okay, yeah. Format, right? So you can add the formatting thing, right? So format, right? Var name, right? Priority. But this is actually, let me look it up here again. Format, right? So unary, right? Format 2 for details. Okay. Right. So kind of. Let's see. Okay, but we'll deal with it later. Let's run this one here, right? So it should print all numbers, right? Print numbers, right? So base case, right? So base case, we do nothing, right? All right, let me just make this bigger so you can see this. All right, so let's run this. Let's just save, right? So if I remember correctly, again, unfortunately, CodeSpace doesn't have history. I thought maybe, yeah, it's erased each time I shut down the machine. So let's do this. I'll go to Clojure for Prolog projects, right? And I believe this will work if I remember correctly, right? And I'm just winging it, right? So let's see if this works. Print numbers, but of course you need to run it, right? You made query, right? That's the thing is, let's run it. Let's run it. Let's run. Let's run this. Let's because defining doesn't of course do anything. So let's create a query that will print numbers, right? Right. So this is the question. Numbers x, right? So look at this here. So kind of weird, right? So numbers x. So we're doing a conjunction basically, right? We're saying we want to whatever numbers are, right? You match it, and then whatever you do, you print it. You use that to print, right? So find whatever value of numbers is, and then print it, right? Really awkward, right? But it works. It's not so bad actually once you think about it, right? So let's see. Only thing is running it. Why does it doesn't want? It wants to comment it because we had this before. Math, right? Yeah. We did this Fibonacci. I guess it wants to. We want to run it first, right? Okay. So let's see what happens. Yeah. And so now if I do this, so numbers x, right, print numbers, right, x, right. Yeah, and it worked, right? So it printed all the numbers and also displayed the bound value, right, which is x in this case, right? Because the free variable, the variable we define. Okay, but you guys all understand why this works, right? Head, tail, recursion, basic stuff, right? Easy, easy. But the way again, it's like that. It's completely the approach from all other. I don't know of any other language which does it like this way, basically, right? So kind of weird if you want to do some basic things like output, right? So the question, okay, now let's see if you can actually get it in a standalone program, right? So let me halt this, right? So because what you would want to do is, can we do it here? Like I said, can you do a standalone script? We'll see. Will this work? Numbers x print numbers, right? Let's see. It might. let's see if we can Google this after. Maybe we'll leave this for the break because I don't think this will work, right? It'll just complain. Yeah, you see, full stop clause, right? You cannot redefine, right? So this is a query. So let me see. Query in a Prolog file. Yeah, yeah, but that is it, right? That's we do it manually, right? But I want to do actually to do it right. Run a query within a program, right? Yeah, this is a question of Stack Overflow like 7 years ago, right? Yeah. ISO direct. Okay. ISO, right? Okay, this is the guy said this looks kind of fun. So we have our file, right? No. Yeah. Okay, let's see. This also C Prolog. Okay, for all. That's one way. You see, this is all funky. Run. This one, I think I like this one the best. I think. Let's see. This says run, right? There's like 3 ways. I would like to make it a script. If you want to make a script for some really weird reason, you'd like to make a Prolog script, right?
You have an inference task or something.
Yeah. You want to run it. So exactly. Yeah, you could run it for nim, right? Good idea actually, right? Okay. So because usually, of course, you could process things, right? So. This will work, right? This is basically for all loop, basically, right? For all dog x, right? Right. Yeah. Let's try this. Let's try this approach. Let's see if this works, right? For all dogs. Well, for not all dogs, but let's try this. Kind of interesting. So let me give a link to this for the question. So this doesn't work, right? So oh yeah, it's using. I think it's a I don't know. Right, so it doesn't work. We won't do this. Yeah. Let's see. No, I don't want the engine. Let's see. Let's try this again. So this looks like a for-all loop, right? All right. So for all, right? We don't have, of course, dog. We have numbers x, right? On print numbers x, right? Print. Oh, but I shouldn't. Print numbers x. Okay, let's take a look what happens now. Do you think it'll work? We'll try. Let's help. I could have a consult. I could have, of course, consult the program also, of course, right? So, all right. Let's see. So it's an empty rule, right? Yeah, it worked. It printed out the values, you see. Yeah, and then it opens and then leaves the. So I wanted to you halt. Could you stop it, right? Because it runs the program. So it basically finds all instances of this, right? Because if I have another numbers, right? Numbers, numbers, 1, 2, right? This is also right. So run this one too, right? No problem, right? So let's try this again. So let me do this consult. If I remember, consult. I believe it was like this: list ops pl, right? If I remember correctly, right? Maybe I'm wrong. Oh, error. Dictionary express phone list ops. Dictionary consult. Maybe I did it incorrectly. Consult. I think it was. I want to. Consult. Let's double check again. Consult. So lots of commands. But yeah, read file as a Prolog source file. Oh, why can't I guess I don't need a consult. Load or all PL. So what's the problem? Why I did this? I did that. Okay, let's do it again. How? All right. So see Prolog. Oh, because I'm not. No, I'm in projects. So consult. All right, and I'll do list ops. Right. Okay, I entered. Oh, happened, right? So it printed out both lists, right? Print both lists. So what we could do, let's modify this program a little bit, right? When it's nothing, right? When we have nothing base case, right? We don't do a recursive call, but let's do print a new line, and let's not print a new line here, right? Because I'm lazy. Let's do this, right? Right, right. And in here, right? This is the base case. We'll print new line. So base case, we will print new line, right? And this is so. Right. I wonder if this will work. It should work, right? Right. Oh, let's see this. Okay, or new line, right? Let's see this. Is this gonna work? There's no recursive call, so it's a base case, right? Let's see. It should work. And now, can we reload? Why can't we consult? Why doesn't consult work? Load files. It should work. So consult list ops. Okay. Operator expected. So what's the problem? This actually it worked, but there's a problem. It didn't like operator. So 12, right? Print numbers. Goal fail, right? Why did it fail? Let's see if we can debug it, right? Let me halt and try it again.
You can also add another line at the end
Yeah.
in your Prolog file.
Yeah.
Colon dash halt.
Oh, here, right? You mean here, right?
Yeah.
Yeah, that's a good idea.
Like this.
Then it should quit.
Yes.
Yeah, and then it should be all done, right? So let's try this now. Oops, no. So it's saved. Let's do it. Are we ready? All right. So it works. We quit. Everything worked except we get the syntax. So this approach does not work with the base case. Maybe this part here it doesn't like this comment. Let's see. 12. Well, the problem is here for some reason here. Let's see. Goal failed. It got too loose for some reason, right? So it had to. Okay, let's go back to this for now, and then see. All right, there's a dot here. Right? Print numbers. Maybe you have to do an L, and then yeah, it's not right. Let's try this again. But please, what's the problem now? Did we do something? Okay, right, and what is it, N here? Comma, there's missing comma, right? Yeah, there's a comma needed here, right? Yeah, that's it, okay. So now it works, yep, it works. Okay, this is just a syntax error, right? And now it should work here. Okay, let's try this again. So, you see debugging is much harder, right? So, right, simple thing I'm trying to do, right? New line. Right. Come on, new line. I'm not trying to use Fahrenheit. Right. On this one, I need to do it like this, I think. Okay. Does this make sense now? Basically, I don't want to put them all in one line. I want to just put them all in one big, right? And if I remember correctly, I used to do this, right? I like space or something. I don't know, right? Okay, let's try this now. Will this work? What do you think?
Yes.
Yeah, it works. All right, guys. So this works. I'm going to commit it to our list operations in Prolog. Yeah, commit so you guys can check the code and you know if your code doesn't work, at least this current version works. All right. No. All right. So halt, yeah. So if you want scripts, this actually is kind of cool. Well, you can have a Prolog script now instead of Python script, right? And again, so you can read files, of course, as well, right? All right. So of course, member, right? You can check, of course, membership. Of course, you can append, right? right? Length, of course, we saw. Um, there is also reverse. How about doing in reverse, right? Let's do it reverse, right? Right. So let's create a predicate that prints numbers in reverse, right? So a couple ways of doing it actually, right? But one idea is basically we're gonna check and then we're gonna check for reverse version of the list, basically reverse, right? So base case, right? And then so one approach, head tails. Right head, this looks, let's see, this looks right, T, okay, yeah, you see, okay, yeah, you see the tricky part. So what it does is it makes a recursive call to the tail, right? So this means that eventually there will be, this should,
one.
yeah, only one item, right? And it will be from the tail, right? So when you unwind this recursive stack, right, then you will end up with the reverse list, basically, right? So let's take a look. So we'll do it here, right? Okay, so for all numbers, again, I'll do a different one. Let's say y, it doesn't matter really, but print numbers reverse, different value, but so for all numbers, print numbers reverse. All right, let's see if this works. Yeah, it works exactly, but yeah, I think there's an extra new line. Oh yeah, there's a new line here, but it did not, well, looks like it did not execute this one here. Why isn't it, this worked fine, right? And I wonder why this didn't fire, right? Because that's the only interesting thing about this, right? Everything else worked fine. Maybe because it adds a new line before everything. Yeah, that's the thing. So it starts out, the base case is a new line basically, right? But you don't get a new line at the end basically here. Okay, but that explains the fact, right? So, all right. How about printing even numbers? Well, that's easy, right? How about uh, how about how about how about predicate that prints even numbers, right? Or fizzbuzz basically. Fizzbuzz, right? You can do a fizzbuzz in Prolog, right? Based on print even numbers, right? So basically, look at this here, right? It's going through this, right? O is H mod 2, right? No reminder. That's the first fact. So the only question now is this actually going to work? Is it going to stop early, right? Because if basically what happens, if this is true, right, it continues doing. These are side effects. So side effects, you get it, you put them in after something true, right? And then you call this part here. So the thing is, what's interesting is this actually going to stop? I'm not 100% sure right now. It looks like it should stop at 0, right? And only print the first number, right? Let's take a look at that one. It should, yeah, print even numbers, Z, right? All right. So let's take a look if this works. I'm not 100% sure. Warning, okay. Goal failed, right? It's warning me, it didn't print anything, right? So the reason AI failed here, because if this fails, right, we don't get a recursive call at all, right? So we need a disjunction here, basically, right? So what we do is, I know what we do. We could add another fact, right? Let's do another one, right? So yeah, I think we need this one, right? Yep. You see, you need the case, the other case, right? You need, what do you do when you have a odd number, right? You don't print anything, you just do a recursive call, right? So now I hope it works. If this works, we can take a break. If not, we'll have to continue working. And no, it didn't work, unfortunately. Okay, now we're getting better. No, we got actually pretty far. It worked. I know it didn't work, right? What's the issue? Everything worked, but what worked? What's the fail? Here, you see? I have two different types, you see?
So we can just comment out one.
Yeah, I'm gonna comment out this fact about the world, right? I'll get something else. I'll add some numbers, you know, maybe like 5, you know, 8, you know, 7, you know, 7, whatever, thousand, right? On, you know, 5, you know, 7, or 9, whatever. Oh, no, 1, right? Okay, so it should print 8 and 1,000, right? Yeah. Okay. We'll try it. It worked. No, come
No,
on.
it did. You just didn't,
Oh.
escape to the new line.
Oh, where you see it? Oh, here?
Well, you can just.
Oh, no, this is different. It's a. I was using a shortcut for, you know, I'm using Control// and it, for some reason, in Visual Studio Code thinks you should be using hash.
But it did work correctly.
It did work.
You see, there's 2, 4, 6.
Yeah, I saw it. Yeah, I saw it worked actually, right? It just there's some syntax error. So let's try this again. Yeah, it works perfectly now. All right. So we can print them in reverse. We can print them only numbers you want, right? You can print the odd numbers and so on and so on and so on. Okay. So now let's see. You want to print. How would you? If you want to do some header, right? You need to wrap it in probably, and then yeah, if you have to do a wrapper before you call the recursive function. Yeah, like you want some greeting or something, you know, right? Then you have to do. But again, these are of course are not the strength of Prolog to printing things, right? It's not what it's not like what it wants to spend time doing. It wants to spend time matching patterns, basically, right? Solving Sudokus and things like that, basically. That's what it's good at, basically, right? It's not really good at printing things. Okay, but you get the idea how it works, right? Hopefully, at least, roughly, right? Sort of, or not yet, not really. The idea of recursion, of course, is clear, right? Yeah. So
like discrete structures.
Yeah, it's like. Do you do something? What do you do in discrete structures or something like this?
Well, we did exactly this.
Yeah.
But on paper.
On paper.
Pen.
Okay. So now, of course, you get to do it Prolog in Prolog.
Yes.
Right. Okay. Right. I know. Like I said, it's not something. Like I said, I would say 90% chance that you will not see this in industry. But when you sometimes see it, you know, when you see this ability, okay, yeah, I could use Prolog for this, right? And then you can be like a wizard, basically, right? You can solve this, right? Because, like I said, you would not use Prolog as part of regular program. You would include it, embed it in another language, like in a Rust or Python or, you know, I think there's a Python, like you mentioned, there might be a Python Prolog. Let's see, Python, PyPy. Let's see. Let's take a look. Like I'm just gonna do rough check Prolog fastly. All right. No, that's logging. That's not what it is. Prolog interface for humans. Prolog interface. Keep it easy. It's a Prolog object interface for humans. What the heck is that? Let's see. The Jupyter kernel. This is what I would like to use, right? This is something I'd like to use, so I can use my notebook format. And there's this guy is basically tester dictate like, but not much information about this, right? Okay, where do we go? Maintainers. Where is the release history? Like not very, how should I say, promising.
I have a question. Hypothetically, if I define these predicate functions in C language, will this Prolog still be more efficient than?
Yeah, because I mean, like I said, you have to write your own inference engine for it, right? I mean, for things like if you have bigger fact world, right? How are you gonna, you know, you have to come up with your own algorithm for finding these facts, basically, right? So, I mean, you gain, of course, you know, regular C language features, right? So the idea would be there is embeddable Prolog. I'm pretty sure, right? So embeddable, right? Prolog C. I'll do C. Yeah, like here, this is the information, right? So, yeah, main problem. C, C++, Java, right? So, external language, right? So it comes with built-in C bindings, which work with C++ of course too, right? So this is how you do it basically, right? Initialize, right? Your main, right? And then you can start using your Prolog basically, right? You got to include something, right? Of course you got to include something, right? So yeah, include the header, right? Right. Now, so it's technical, so that's how you do it. All right, guys, let's take a break.
Sure.
All right, so we'll continue around 12:10.